All right, so for this one, we have a right triangle. They give us a side length and the angle. And it says determine the number of significant digits corresponding to the information given in the following triangle. Measure of an acute angle and the side length. In solving a right triangle, what number of significant digits should be used? So significant digits are really about levels of precision. We talk about this all the time. Since a lot of this stuff is used in science, that's probably a good time to talk about it in a math class. So what does that mean? Well, first of all, we have to identify the values that they've given to us, right? So beta is equal to 45 degrees. That's a value they gave us. And then the corresponding side they gave us was 27.3 feet. Now, remember, like on these different trig problems, if we plug them in your calculator, it's like the square root of 4. Well, that's not a good example. Square root of 2 or the square root of 3. These are irrational numbers. That means they're non-terminating, non-repeating. So the decimals go on forever. So we're going to have to round. So the reason that we're talking about significant digits is because we need to know how many decimal places to round. And significant digits help us to identify the level of precision that we need to round to. So in this particular case, first let's identify the sig figs for this one. So this one is actually 2 significant figures. Okay, I have 1, 2 digits. This one here is 1, 2, 3. Okay, and so when we go to solve this triangle, in other words, if I go and I do a bunch of work and I find this angle and I find this side length and I find this side length, when I go to do all the math, I'm going to have some decimals. And I need to figure out how many significant figures or digits I should say. I shouldn't say sig fig. I should say significant digits. That's what the textbook says. Okay. So what do I do? Well, it says in solving a triangle, the remaining side lengths A and C should be expressed in 2 sig figs, or 2 significant digits. So A and C should be two significant digits, because that's the level of precision that I'm measuring it. Okay? That's the level that I'm measuring it. That's the level of precision that I'm measuring it. So, for example, if I crank through, and we'll do an example of this after this, I'm going to crank through and do the math, and I might find that this side length, when I crank through and I do the math, it might be like, I don't know, 29.56372. Well, I should only do 2 significant digits because that's the lowest number of digits that we were using to measure. Does that make sense? So I'm gonna jump into example number 2. Does everybody have this written down? Can I jump to the next example so you can see this in action? I'm going to combine the two because there's kind of a flow to this. So when we go to example number 2, they want us to solve this triangle. Okay. Now that means they want us to find A, B, and C and the angles. So we have to list the angles. So my angle A, or alpha, is 27 degrees. They want me to find beta. I got to figure that out. And then this remaining one, you could call gamma. I think that's what your textbook uses sometimes, gamma. We know that's 90 degrees, right? Then the corresponding sides. Notice that the lowercase is used to represent the sides, A, B, and C is always the hypotenuse, right? So what you want to do when you go to solve this thing, we're going to have to use some sort of trig stuff, trig math. So this is going to have to be, if this is the angle that they've given us, then we label it accordingly. C is across from the 90-degree angle, so that's the hypotenuse. A is across from the angle, so that's the opposite. B, the side length B, actually touches the angle, so that is the adjacent. Okay? Well, they tell us that B is 14. Okay? Now, the next thing I need to do is I need to figure out what beta is. Well, I know that alpha plus beta, that's a very bad beta. Alpha plus beta has to add up to 90, right? That's from like yesterday or the day before. So then if alpha is 27 degrees plus beta equals 90, then I simply subtract 27 from both sides. Okay? These cancel, and I get beta is equal to, what's 90 minus 27? Is that 63 or 53? 63. Okay. So over here, I'm going to write down 63. Now, what they've given us is they've given us an adjacent, and I have to plug in the values of what I have. So if I use alpha, that's the given value, even though that I've identified this as 63, you always want to go with the given value. So what do you guys want to solve for? Do you want to solve for lowercase a or c? Which one do you want to solve for? C? All right. So C is the hypotenuse. Well, they've given us A. So I need to remember SOHCAHTOA. This is the hard part for most kids. You got to figure out which trig function you're going to use. We have an angle, but we have the adjacent and the hypotenuse because we want to solve for C. So which one has the adjacent and the hypotenuse? Cosine, right? Adjacent and hypotenuse. So I'm going to say cosine of 27 degrees is equal to the adjacent, right? What's the adjacent? 14. And then what is the hypotenuse? Well, that's C. And we don't know what that is yet, right? Okay. Well, cosine of 27 degrees is actually a number, so I can solve. First thing I need to do is move this C out of the bottom of this fraction. So I'm going to multiply by C over here, but whatever I do on one side of the equation, I have to do to the other. These C's cancel, and I get C times cosine of 27 degrees is equal to 14. Okay? Next, I'm going to divide both sides by cosine of 27 degrees. Because cosine of 27 degrees is an actual number. These cancel, and I get C is equal to 14 divided by cosine of 27 degrees. Now, that's not too difficult to find. I'll give you a second to write that down. I forgot to pass out the calculators. Does somebody want to pass out the calculators? you don't need it. Well, here, I'm going to set these up here. If somebody wants to grab these and pass these out, it's not a bad idea to plug them into the calculator. I'm going to do it on the screen. But help yourselves. Or you can just watch. So what I'm going to do, does everybody have this written down? I know a lot of you have your own calculators. So what I'm going to do is I'm just going to plug in a calculator, 14 divided by cosine of 27 degrees. Now make sure that your calculator is in degree mode, for sure. Man, I'm struggling with this. Someday they'll have my calculator set up on my computer. Probably May. All right. So then, of course, you could barely see it. So I've got 14 divided by cosine of 27 degrees. Okay. Then I hit enter. It's about 15.71, right? All right. So we've discovered, and I'm gonna just write it out. It's equal to 15.7125. It goes on forever. And dot, dot, dot. But now what I got to do is I got to figure out, what do I round this to? Well, if I look at alpha, alpha had 2 significant digits. The other term that they gave us was B. That also had 2 significant digits. So you choose the lower, but they're both 2 significant digits. So what I have to do is I have to round this to 2 significant digits. So that means I'm going to round it to 16. And because I rounded it, instead of saying equals, I'm going to put the little squiggly line. Does that make sense? Now, how do I solve for A? I do the same thing, but now A is the opposite. So I'm going to go through and do the same thing, but I'm going to use sine. So if I say sine of 27 degrees, remember that it's the opposite over the hypotenuse, right? The opposite over the hypotenuse. So on the top, I have to plug in the opposite, which is A. And then on the bottom, I have to plug in the hypotenuse. I can round that or put it in. Technically, what I should do? Erase that. We should go with the given one, because we should always use the given values. So if I go with the given values, what did they give me? They gave me the adjacent. I want to solve for the opposite, so I'm going to use tangent. So I'm going to say tangent of 27 degrees. Remember that tangent is the opposite over the adjacent. I don't know what the opposite is, so I'm just going to label it A, right? That's because the opposite is A. All over the adjacent, which is actually B, which is 14. Now this one will be a little easier. I'm just going to multiply by 14 over here and multiply by 14 over here. These 14s cancel, and I get 14 times tangent of 27 degrees is equal to A. So I'm just going to plug that in the calculator. 14 times tangent of 27 degrees. Hit enter. And I'm rounding to 2 significant digits. So what does that round to? 7.1. So this will round to 7.1. And that's it. We've solved all the sides of the triangles and all the angles. Any questions on that?